My name is Jorge Gomes and I'm Technical Coordinator of the Portuguese National Distributed Computing Infrastructure. Conventional infrastructures are facilities and systems that provide important services to countries and regions. They can include airports, dams, railroads, roads, bridges, water supplies, electrical grids, and others. Likewise, e-infrastructures are digital facilities that comprise hardware, software, and networks at several locations and deliver IT services to certain users within a given community or geographic region. E-infrastructures are usually meant to support researchers and engineers in their R&D activities, but can also provide services that can benefit society as a whole. They provide state-of-the-art computing, storage, and data processing services. These services can be very generic and therefore usable by everyone, but can also be very specific, tailored to the needs of a given user community. E-infrastructures are based on advanced IT facilities comprising hardware, software, and networks, typically publicly funded, although may also include commercial providers. E-infrastructures address the issue of how to currently use different computing data and other services that can be provided by several providers geographically distributed. Examples of typical issues that users face when trying to combine and use many services are how to discover the available services, how to use and manage the logins across the several services, how to combine and use the several services. E-infrastructures enable the federation of the several compute and data resources over the Internet so that the users can find the available services, the users can have a common login across the several services, the users can access and use the several services in a very similar fashion. E-infrastructures can have national, regional, or international scope. Examples of country-specific infrastructures are, for example, INCD in Portugal, ESNGI in Spain, SURF in the Netherlands, PSNC in Poland, and GISC in the United Kingdom, among many others. Some examples of international infrastructures are G1, that provides the European Academic Network backbone, EGI, that federates compute and data services in many countries worldwide, UDAT, that provides data-oriented services, and PRACE, that provides access to high-performance computing machines. E-infrastructures can also be domain-specific, serving a particular community or domain of activity. For instance, LifeWatch provides services to the biodiversity community. WLCG provides services to the physicists working at the CERN Large Hadron Collider experiments. Daraya is focused in arts and humanities. Several domain-specific infrastructures are built on top of the national and international ones, and thus rely on them to build and deliver their own specific services. In this presentation, we will focus on the European Open Science Cloud, EGI, and UDAT infrastructures. Taking the European Open Science Cloud, EOSC, as an example, EOSC is an overarching initiative from the European Commission to provide several types of services and tools for specific computing and data processing. EOSC acts as a hub for computing, storage, and other services provided by other infrastructures, such as the European Grid Infrastructure, EGI, and UDAT, merging them and offering a single point of contact and common access to different services. The services include, among others, scientific data repositories, generic storage, computing and connectivity, thematic services targeting specific research communities or scientific domains, complemented by training, consultancy, and support. To support the delivery of these services, EOSC includes a marketplace to expose the services to the users, authentication and authorization to enable common login across the federation, accounting and monitoring of the services. The EOSC Hub project is building the basis for the European Open Science Cloud. Besides the generic services, EOSC is working to provide specific services targeting multiple scientific domains and user communities in humanities, engineering, medical and health sciences, and natural sciences. The services are available through the EOSC Hub Marketplace, which is a web platform to promote, discover, order, and access the services. Users can authenticate and register to browse the marketplace and request services that are built and delivered on top of the underlying infrastructures such as EGI and UDAT. EGI is a good example of a large international infrastructure. EGI federates more than 350 providers, which can be individual organizations or national infrastructures. Overall, EGI has a capacity of about 850,000 CPU cores, 300 petabytes of online disk storage, and 350 petabytes of archive storage. The users are grouped in research communities named virtual organizations. There are more than 230 virtual organizations and 31,000 users. Each provider can choose which virtual organizations wants to support. EGI targets multiple users. For the multinational projects, EGI offers services to federate and share the data and compute resources of the participating research organizations. EGI offers services to coordinate the operation and usage of the federated resources, and EGI offers training on IT service management, among others. For the research groups, EGI offers seed computing and data storage capacity, and EGI also offers support and training. Let's see some of the EGI services and what they can do for you. EGI provides access to batch processing clusters composed of Linux machines. This service is mainly oriented to the execution of many programs where each running program does not interact with the others. This is called high-throughput computing. Users can submit the programs to batch clusters in the EGI Federation at many geographic locations. The submitted jobs wait in a batch queue until enough resources become available. EGI also offers a workload management service that enables the automated distribution of the programs across several batch processing clusters. Why use the EGI high-throughput compute service? This type of processing is used in many scientific areas to execute sequential or multi-threaded programs. Each program runs within a single computer in the batch cluster using one or more CPU cores. A batch cluster may have hundreds or thousands of computers. The service can easily take advantage of idle resources and compute capacity in the EGI Federation. It is suited both to CPU-intensive and I/O-intensive applications. With Workload Manager, the exploitation of multiple batch processing farms at several locations is facilitated. In this case, the programs to be executed are submitted to the Workload Manager that queues them locally and takes care of submitting them to multiple batch clusters in the Federation according to their availability. EGI also offers a federated cloud computing service that allows access to multiple cloud providers. This service enables users to create and execute virtual machines at different cloud provider locations. Machines are created and started via web portals or via programming interfaces. Cloud computing is mostly targeted at the execution of long-running services such as databases, web servers, scientific gateways, platforms, and data repositories, but can also be used to execute applications that cannot be run in batch mode. Comparing cloud computing versus batch processing. Cloud computing allows long-running services, while batch jobs are limited in time to days or hours. With cloud computing, users can control the complete execution environment, including installing software and configuring the virtual machines, while in batch processing clusters, users are usually limited to the software and configurations available in the batch cluster. With cloud computing, the virtual machines are started immediately or fail, while in batch processing, the system takes care of the jobs by placing them in a queue and executing them when the needed resources become available. With cloud computing, the users need system administrator skills to configure the machines, while in batch systems, this is done by the local system administrator. EGI also offers storage services, namely online storage that can be used directly by the processing tasks for input and output and can be delivered by storage systems at several locations, usually near the cloud or batch computing services. Archive storage is another service that is meant mostly for backup and long-term retention and whose access is usually slower. On top of the compute and storage services, EGI also offers value-added services, such as access to predefined and pre-prepared software applications and platforms commonly used in science and engineering, access to Jupyter notebooks that allow creation and sharing of documents that contain live code, equations, visualizations, and narrative text. An example of a national infrastructure is INCD, the Portuguese Distributed Computing Infrastructure. Like many other similar infrastructures in Europe and elsewhere, INCD is a publicly funded e-infrastructure that provides compute and data services to the Portuguese academic and research communities. It is integrated in both EGI and EOSC, enabling the sharing of its resources at international level, supporting many services delivered by EGI, EOSC, and other entities to the scientific community. The objective of INCD is to support national R&D projects, large international research projects, participation in scientific infrastructures such as CERN and other European scientific infrastructures like the ESFRIs, and it delivers cloud computing, high-throughput computing, and high-performance computing services. Let's see the details of deploying a particular service on EOSC. OpenCodes provides on-demand forecasts for selected coastal areas. The service has been developed by LNEC and has been made available to the European researchers via the European Open Science Cloud. OpenCodes sits on top of computing and storage resources provided by INCD in Portugal and IFCA in Santander, which are part of the European Open Science Cloud through EGI. The OpenCodes web portal can be accessed directly or from the EOSC Hub Marketplace. Authentication in the OpenCodes web portal is performed with the EGI check-in service, which allows several types of authentication. The virtual machines that support the web portal, backend, storage, and databases are hosted at the INCD and IFCA cloud services, which are part of the EGI federated cloud. Additional computing capacity can be obtained from the EGI high-throughput compute service via the EGI workload manager. Long-term storage can be provided by the EUDAT data storage services like B2Safe for long-term storage. The benefits of using e-infrastructures. With e-infrastructures, users can access scientific computing and data services that are tailored to research and engineering. They can explore the capacities and the capabilities of the available national and international resources. They can access a large portfolio of scientific computing and data services that has added value. They can combine this service to match their needs. They can benefit from the single authentication and authorization mechanisms to access all the services. They can benefit from the excellent network connectivity of the European network backbone. They can obtain better redundancies through the usage of resources that are available at several locations. And they can interconnect the compute and storage capacity that they have available to their own projects. They can store, find, and share data collections and analyze the data. And they can create services and portals to explore and share the data. For further information, consult the web pages of the following infrastructures. For Portuguese users, consult the INCD web pages. Thank you for your attention.